Hello students. This question we're going to be focusing right now is on a uniform distribution. The key reason we know it's a uniform distribution is because it says in a uniform manner. That implies that we are dealing with a uniform distribution. So we have a number ranging from 16 to 68 in a uniform manner. So that means that the lowest value that a number can take is 16 and the highest value it can take is 68. So here when we have A is our lowest value, which we can change to be 16. And 68 is our highest value, which is B, which we can change right here. All right. So now it says, based off that information, what is the mean of the distribution? As we talked about before, E of X is the same as mean, so the answer is 42, which we see here. And then it says standard deviation, we get 15.0111, which is what we get here. And then the C asks us, what is the probability that the number will be exactly 66? So finding the probability of X is equal to 66. When we have an exact value when we're dealing with uniform distribution, the probability of an exact value is happening is 0. And the reason for that is because there are infinitely many numbers in between, like 60, between 60 to 61, from 65 to 66 to 67. There are infinitely many numbers that could become 66 due to rounding, so therefore an exact probability of that happening is 0. So if we have here the probability that a number will be between 27 and 55. So here we have C and D, which as you can see how it lays out right here, can be our beginning one and our end one. So if we change C to be 27 to go with the smallest value, and D to be 55 to go with the biggest value, and we go to the one that looks most like what our problem of probability is here, we're going to get the answer of 0.5385. And that's what we were looking for right here. Now we're looking for a number that's larger than 32. So as you can see, 27, we have X is less than 27 and we have X is greater than 27 from the last problem. So if we change 27 into 32, now we can find X greater than 32, which is this one, which results in 0.6923, which is good for that. Now when we have a line like this, it's known as a given function. So we want to know the probability that X is greater than 24 given that X is less than 65. So we've now changed how high the value can be. It has to be less than 65. So right now we have the highest value being 68. We need to change this value right here to be 65. And now we can calculate the probability of it being greater than 24. So now we're going to change this to 24. And so now we can click on the probability that X is greater than 24, since we've already told it that the highest it can be is less than 65. So we have 0.8367 as our answer, and that matches here. Now, when it wants us to calculate the 63rd percentile, this is assuming that we have the range that we originally given up here, which is 68. So we need to go back and change this 65 to 68 before we can do the percentile. So we change this to 68. Now it says find the 63rd percentile. So we're going to change this value right here to be 0.63 to represent the 63rd percentile, and we get the value of being 48.76, and we find that here. Now it says find the minimum of the upper quartile. Quartiles are when the values are being divided into 4, so then we have the 25th percentile, the 50%, the 75, and the 100. So the lower quartile is going from 0 to 25. Then the two middles are going from 25 to 50 and 50 to 75. And then the upper is 75 to 100. Since it wants to know the minimum of the upper quartile, we can say 0.75 to represent 75%. So if we change it to 0.75, we get a value of 55, which matches what we have here. If you have any questions, I highly encourage you to email me.